In section 12.1, we're going to look at probabilities and odds. So first, let's start with some vocabulary. An outcome is a possible result of an experiment. So for example, when you flip a coin, there are two possible outcomes, flipping a heads or flipping a tails. An event is an outcome or a collection of outcomes. So back to our first example, if you're flipping the coin 5 times, the event would be how many times did it come up heads? How many times did it come up tails? The sample space is the set of all possible outcomes. Let's see an example of finding all of the outcomes in a sample space in the next example. So here's example number 1. You flip 2 coins and roll a number cube. How many possible outcomes are in the sample space? List the possible outcomes. So again, we're going to write out our sample space by listing all of the possible outcomes. So let's look at the 2 coins first. We have a possibility of flipping a heads or a tails when we flip 1 coin, but we're talking about 2 coins. So let's list all the possibilities. You could flip a heads on the first one and a heads on the second one, and then roll the number cube and roll a 1. You could do a heads and a 2, a heads and a 3, a heads and a 4, heads and then a 5, and of course a heads and a 6. Then we could do a heads and a tails and a 1, a heads and a tail and a 2, a heads and a tail and a 3, heads, tails, 4, heads, tails, 5, heads, tails, 6. Then we could do a tails, 1, a tails, 2, tails, 3, tails, 4, tails, 5, tails, 6. And something that maybe you didn't think of is what if you flipped a tails first, then a heads, and then got a 1. Tails, heads, 2, tails, heads, 3, tails, heads, 4, tails, heads, 5, and tails, heads, 6. So that would be different than flipping it and getting a heads then a tails and a tails then a heads. So there were 6 here, 6 here, 6, and 6. So 6 times 4 would be 24 possible outcomes in our sample space. And here's a reminder from section 11.4, because if you remember, we have talked about probability before when it came to geometric probability. So again, the probability of an event is the measure of the likelihood that the event will occur. It is a number between 0 and 1 inclusive, meaning we can include 0, like you could have a 0% chance, and 1, meaning you could have like a 100% chance. And it can be expressed as a fraction, a decimal, or a percent. And just remember that if you have a probability of 0, that means that that event has an impossible outcome. You could have a 50% likelihood, which means it's equally as likely to happen or not happen. And if you have a 100% outcome, then you know absolutely that that event will be certain to occur. And now we move on to theoretical probability. And the way I think about theoretical probability is that in theory, this is what should happen during my experiment. Is that necessarily what's going to happen? No, but in theory, this is what should happen. So here's some vocabulary circling around theoretical probability. Favorable outcomes are the outcomes for a specified event. And as for theoretical probability, when all outcomes are equally likely, it can be found by using the formula where you take the number of favorable outcomes over the total number of outcomes. The probability of event A is written as P of A, but read as the probability of event A. We've seen that before, again, when we did the geometric probability. So here's example number 2. A department store is offering a discount on sunglasses. The table shows the number of each type of discounted sunglasses. You choose a pair at random. What is the probability that the pair you chose is polarized? So looking at the table, we see 2 different options where we can get them either polarized or mirrored. And within those 2 options, they can either have green lenses or brown lenses. So the first thing we need to do is figure out our total number of possibilities of sunglasses we are choosing out of. So for polarized, we would have a total of 12 pairs that we would be choosing from. And for mirrored, we would have a total number of 16. So altogether, we would have 28 pairs of sunglasses that we're choosing at random, one pair. So our question is, what is the probability that the pair you chose is polarized? So we would write that as the probability that the pair that we choose is polarized is equal to, we're going to do favorable outcomes over total outcomes. So we know the total outcomes is 28, and our favorable outcomes are the polarized. The polarized were the 12. So we would put 12 over 28. I'm going to write it as a percent. So 12 divided by 28 is about 42.86%. So I just took 12 divided by 28 in my calculator, moved the decimal point 2 places to the right, and again, I got about 42.86%. So let's move on to example number 3. You toss a coin and roll a number cube. What is the probability that the coin shows tails and the number cube shows 4? So first, let's list out our sample space. So we are flipping a coin, and so we could either get heads or tails, and then we're rolling a number cube, which has 6 different sides. So we could get a heads and a 1, a heads and a 2, heads 3, heads 4, heads 5, and heads 6. And then I could also flip the coin and get a tails, and then roll the number cube and get a 1, tails 2, tails 3, tails 4, tails 5, and tails 6. So I have a total number of 12 possible outcomes. The question is, what is the probability that the coin shows a tails and the number shows a 4? That happens only once, so that is my favorable outcome. And then I divide that by the total number of outcomes. So we write it as the probability of getting a tails and a 4 would be 1 over 12. And again, I'm just going to put that into my calculator, 1 divided by 12 to get my decimal, and then move the decimal point 2 places to the right to get about 8.33%. So theoretical probability is saying this is what should happen. Experimental probability means that I actually performed the experiment and this is what actually happened. So experimental probability is based on the number of repeated trials of the experiment. When you have a favorable outcome occur during the trial, that is called a success. You can find experimental probability by taking the number of successes divided by the number of trials. So again, theoretical probability is this is what should happen. Experimental probability is this is what actually happened when I performed the experiment. I would write that down so you're sure which one is which when you are doing your homework or answering questions on a test or a quiz. So let's look at example number 4. It says a bag contains 1 blue, 1 green, 1 yellow, and 1 red ball. A ball is drawn at random from the bag and then replaced. The table shows the results for 24 drawings. For which color of ball is the experimental probability of drawing the color the same as the theoretical probability? So let's talk about theoretical probability first. As you are drawing the balls out of the bag, you have a possibility of 4 different outcomes: a blue ball, a green ball, a yellow ball, or a red ball. So if I want to find the theoretical probability of drawing a red ball, it'd be 1 out of the 4. So again, the theoretical probability would be 1 over 4. So now what we're going to do is figure out what the experimental probability was for each of the different colors of balls and see which one is equal to 1/4. So the probability that you got a blue ball would be 4 out of the 24 times that the balls were drawn. So 4 over 24 in lowest terms is 1/6. The probability that you draw a green ball was 6 out of 24, which is equal to 1/4. So we know that the theoretical probability and experimental probability of drawing a green ball are the same, but let's just see what yellow and red give us too. So the probability that I get a yellow ball, it was 9 over 24, which in lowest terms is 3 over 8. And finally, the probability that you drew a red ball would be 5 over 24, which is in lowest terms. So again, our question was, for which color of ball is the experimental probability of drawing the color the same as the theoretical probability? Would be for the green ball, since both of them are equal to 1/4. And finally, this section ends on talking about the odds of an event. So the odds of an event compare the number of favorable and unfavorable outcomes when all outcomes are equally likely. You find odds by doing the following formulas. So for finding the odds in favor, you take the number of favorable outcomes over the number of unfavorable outcomes. To find the odds against, you take the number of unfavorable outcomes over the number of favorable outcomes. Normally, odds are written like this. You would say like 3 to 2 odds. So when I see that, that would tell me that I have 5 different outcomes, 3 in which are favorable, 2 in which that are unfavorable. So let's look at our last example, number 5. It's the same setup as our last example where we have a bag that contains 1 blue, 1 green, 1 yellow, and 1 red ball. A ball is drawn at random from the bag and then replaced. The table shows the results for 24 drawings. The question is, what are the odds in favor of drawing a green ball? When you're doing odds, you're thinking in terms of theoretical probability, not experimental. So we really don't need this part where we know how many of each ball was drawn each of the 24 times. So the odds in favor of drawing a green ball would be found by taking the number of favorable outcomes, which would be drawing a green ball, over the number of unfavorable outcomes, which would be drawing one of the 3 other colors. So again, it would be, we have 1 option of drawing a green ball and 3 options of drawing a ball that is not green. So we have a 1 in 3 chance of drawing a green ball. That's it for this section. Make sure you jot down anything you didn't understand that we can cover before we move on in class, and we'll see you then.